All right, in this video, we're going to go over Module 7, Lesson 3, which is negative exponents. All right, this will be your warm-up for that set of notes, which is actually reviewing our Module 7, Lesson 2. All right, so Module 7, Lesson 3 is about negative exponents, and this is the benchmark NSO 1.2 still, so generating equivalent algebraic expressions using the properties of exponents. So what is the zero exponent first? So any non-zero number raised to the zero power is equal to 1. That means any number. So a to the 0 is equal to 1. So any number, any variable raised to the 0 power, or any combination of numbers, or any combination of letters raised to the 0 power is always going to be equal to 1. That makes it really easy when we're simplifying or making equivalent expressions. So here we have negative 8b to the 5th, c to the 7th, d, all over 9b squared to the power of c. That whole thing, because it's in parentheses, is raised to the 0 power. So that is going to be equal to 1. Here we have a to the power of 4, b to the 0 power, all divided by a to the power of 2. Because of this b to the 0 power, we're going to treat that as 1. So then we're just left with a to the power of 4 over a squared, which using our division properties is a to the 4 minus 2, which is a squared. Okay, here they have b to the 0 power down here in this denominator. We have c to the 0 power down in this denominator and d to the 0 power. So those are all going to just simplify to be 1s. So we just have 56 divided by 8, b to the power of 2 over 1, c over 1, d to the power of 11 over 1. So once we simplify that, this is what we can simplify that to. And then we simplify that further by doing 56 divided by 8, which is 7. And everything in my numerator remains in my numerator. And so I no longer have a denominator here. Okay. Then we have d, our example d. So we have 2x to the 0 power, y squared, z to the 0 power, all being divided by 5x to the power of 3, y to the power of 0, and z to the power of 6. So every time I have something to the 0 power, I'm going to take it out, and I can replace it with 1 just so that I remember that it's there, or you can just remove it because anything times 1 is itself. So I end up with 2y squared being divided by 5x to the power of 3, z to the power of 6. That's already simplified further. There's nothing else I can do to simplify that expression. Okay, negative exponents. This states that for any non-zero number and any integer n, so any number or integer n, a to the negative n is the reciprocal. Remember that word reciprocal when we were dealing with parallel and perpendicular lines? Of a to the n. So here's an example, and we already talked about this on Wednesday, but a to the negative n is going to be equal to 1 over, so in a fraction, a to the power of n. Okay, so same thing, the opposite. If I have a negative exponent in my denominator, then what that means is I'm going to flip it, make its reciprocal, and that would be equal to a to the power of n. So think of it this way. Just as a positive exponent means repeated multiplication by the base, a negative exponent means repeated division by the base. And I showed you that in the intro to Module 7 notes, how the pattern is division as we are going down in exponents. So we have to simplify each expression, and we're going to always assume that the denominator does not equal 0. So x to the negative 3. So if I have x to the negative 3, I'm going to write that as 1 over x to the third power. If I have 3 to the negative 2, remember that 3 is over 1, so I write the reciprocal. So that's going to be 1 over 3 squared, which then could simplify to 1 over 9. 1 over y to the negative third, okay? That's because the reason why I changed this was simplest form. I need it in simplest form. 1 over y to the negative third If I have my negative exponent in the denominator, what I have to do is flip it. And so I have y to the third power. 1 over 4 to the negative 3, I'm going to flip it. I get 4 to the power of 3, and then I must simplify it. 4 to the power of 3 is 64. Okay, so a to the third, we can group that as a to the third over 1 because there's no a terms in my denominator. B to the negative 4 over 1. I'm probably going to have to simplify that because I have a negative exponent. And then I have 1 over c to the negative 2. Again, I'm going to have to simplify that. So our first step was to write as a product of fractions. So we're going to split each variable on its own. Then we apply the negative exponent rule. So a to the power of 3 stays in the numerator. B to the negative 4 is going to flip, and so the b to the power of 4 now is positive and is in my denominator. Here, the negative exponent is in my denominator, so I'm going to flip it, bring it to the top, and it becomes positive. So I have a to the power of 3, c to the power of 2 in my numerator. And then all that's left in my denominator is b to the power of 4. Okay, I did the same thing with example F. I split all of them. I have 3 over negative 36, so I put my coefficients together. G to the negative 3 over g to the power of 3. I put my g's together. H to the power of 2 over h. And then I didn't have a j in my numerator, so 1 over j to the negative 4. I have to simplify and remove all negative exponents. So I have 1 over negative 12. I can leave that negative there because it's a coefficient. I had to bring the negative 3 to the denominator, and then I can add those two together. H to the power of 2 over h to the power of 1. So I'm going to subtract, and I'm just going to get h. And then 1 over j to the negative 4. I'm going to bring to that j to the power of 4 to the numerator and drop the negative in front of the exponent. Once I simplify that, I get h j to the power of 4 over negative 12 g to the power of 6. All right, now you can try your practice. That's it.